planet Earth. With its oxygen-rich and protective atmosphere, abundant water, diverse chemical composition, abundant natural resources, and moderate temperatures. A set of closely connected systems supporting life for several billion years. The geosciences focus on the exploration, discovery, and stewardship of the Earth. Geoscientists explore Earth systems to better understand its many natural processes.
Keep going.
They search for new mineral and energy resources, discover and validate new theories about the Earth, and are stewards of Earth's three physical systems: the atmosphere, the hydrologic systems, and the many aspects of solid Earth.
Looks like there's a real zone of this right through here.
That's a fault right there.
Okay, it could be this zone could be following that structure there then.
For the 125,000 geoscientists in the United States, the Earth represents a huge outdoor laboratory in which they attempt to wisely manage its natural resources such as oil and gas, water, minerals, and balance society's need for resources with the impact on the environment. Geoscientists reconstruct the past and predict the future by studying the evolution of the planet and its living things. They investigate global change, study natural hazards such as floods, earthquakes, storms, and the forces of dynamic Earth. They work on issues concerning the future well-being of the planet, to develop a better understanding of the Earth's systems, and search for ways of applying their knowledge to manage our world effectively. Weather information is important for everyone, especially in agriculture and transportation.
The actual mission of the Weather Service is to protect people's lives and property from weather-related damage. And in the process of doing that, we end up watching the weather on a day-to-day basis. But really, our bottom line, what we're trying to do is save lives and property.
Hi, this is Chris Strong, the National Weather Service, calling for a balloon launch.
Part of the job is, of course, collecting data. If we're going to figure out how weather's going to be changing in the future, you're going to need a good picture of right now. We do weather balloons to get upper air data, winds and temperatures, ground level information like the temperatures, rain gauge information, wind sensors for direction and speed, any number of things. I actually got into meteorology specifically about 10, 12 years old when we had some big weather events coming through our area, a big hurricane and a blizzard back-to-back, and that kind of got me interested on that front, but I'd always actually been interested in the geosciences. You come in, you get your briefing from the shift before you, you take a look at what's going on meteorologically around you. Yeah, we have, those clouds are going to be coming over here, tomorrow night?
So 36 hours.
Oh, wow. And you get your own personal feel, and then about midway through your shift, you'll get together with the other forecasters on duty. You'll work out a group forecast. Everybody will sound in their ideas, and you put out your forecast based on what the group idea is.
The official National Weather Service forecast for tonight, partly cloudy early, mostly clear later on, possible record lows of 50.
At the Weather Service, your career can work up the normal career ladder. You can go through the forecasting progressions from one step to another, going up the seniority level of forecasting. You can go into Weather Service management if you want to do that. You can also do, you can get out of the Weather Service entirely, do television work. Broadcast meteorology is always an option for people that are interested in science. Me, not quite sure what my eventual path is going to be, but I am very interested in forecasting and be something closely related to that.
Many geoscientists work in solid earth sciences, including geologists at the state level.
My job mostly involves geologic mapping, mapping of different parts of the state of Nevada to address issues that benefit the state and its citizens. The Nevada Bureau of Mines and Geology is really the state survey of the state of Nevada. Every state has a geological survey, much like the Nevada Bureau of Mines. Our mission is to do geologic research that benefits the state. We do things on geologic hazards, earthquake hazards, for example, landslides, floods. We do things on mineral resources, exploration, or information that would help the exploration for various mineral resources, things that address land use issues, the growth around Las Vegas and Reno, and a variety of other things, all centered around understanding the geology of Nevada. In geologic mapping, we try to start in an area that's fairly simple, where the rocks are well exposed and we can understand them relatively easily. And we'll start geologic mapping there. We'll look at the rocks, record what they are, write notes in our field notebook, put information on the geologic maps, in some cases on the aerial photographs. What we look at when we're out there in the field, first of all, what kind of rock is it? Is it granite? Is it basalt? Is it sedimentary rock? Then we want to know something about how it occurs there. Sedimentary rocks can be flat-lying, they can be tilted. We'll use our Brunton compass to measure that kind of orientation, and we'll record this information on the geologic map. We synthesize a lot of our field information back in the office. For example, we'll take all the measurements, the strikes and dips on the sedimentary rocks, put it all together to see if there's a regular pattern. For example, the rocks might be tilted by a series of faults, or they might form a major fold, and by putting this all together on the map back in the office, we can see these patterns that we might not always see when we're working in the field. The end of all this process is a very nice looking colored printed map where all the units are identified by a specific label and a specific color, and then we can actually publish that map and make it available to the public. Teamwork is a really important part of geology. Every geologist has certain specialties, certain skills, they're things they're really good at. And other geologists have other skills. And no one geologist can address every problem, can resolve every issue. And so I bring my geologic mapping skills and others to a problem. Somebody else might be, say, a paleontologist who can identify the age of rocks from fossils. Somebody else might be a petrologist who can understand the geochemical evolution of igneous rocks. And all this ties into understanding, a more complete understanding of the whole geology. Looks like a pretty interesting rock here.
Geologists from different agencies sometimes work together. The mining industry is in part dependent on the work of state geologists.
My specific job is to look for gold. So I do mineral exploration for resources. A lot of the identification of the area to look into happens back in the office using data compilation from previous work people have done and data people have collected. Usually that data is inadequate, so the next step is to head out to the field. When we look for a gold target, one of the most obvious places we start is to look for a place where other people have looked in the past for some kind of resource, gold or silver or whatever. So historic mining does play an important role in modern exploration. We use it as a tool to guide us to areas around or nearby or similar to what historic mining has discovered. Looking at the rocks, mapping the rocks, and sampling the rocks is the most important thing to do. Recording information about what they look like and bringing back samples that we can send to the lab for processing are the most important techniques that I use. Then we have to drill holes in the ground to really see what's there. Computers and technology play a very important role in mineral exploration today. The days of the prospector with mule and pickaxe are over. If we can't take advantage of compiling large data sets in computers and processing information, we couldn't find the large ore deposits that we're looking for to be economic today. The bottom line in operating a mine is that it must be profitable. If you can't produce what you're extracting from the ground at a profit, you can't run a business. Our society today is very much aware of the importance of stewardship of the land in a way we didn't consider 100 years ago. There is an extensive reclamation procedure that actually starts while the mine is still producing and goes on until things have been satisfactorily reclaimed. I think there are many opportunities for young people today in geology in general and in the minerals resources industry in particular. If you enjoy adventure and traveling and especially working in the out of doors, it's a wonderful way to integrate scientific curiosity and puzzle solving with answering the needs for a lot of today's society.
The Orion is an oceanographic research vessel on the Chesapeake Bay.
So my specialty is physical oceanography, which is waves, tides, currents. We're working on many projects. The most important one is the one we're involved in today. It's the biggest effort. It involves about 20 scientists. It's trying to figure out why estuaries in general, why the Chesapeake Bay in particular, is so efficient in growing fish. The interest is to find out how small fish grow and why they grow so well in small little regions of Chesapeake Bay. There are circulation features that create what we call convergences that bring food together where the small fish can eat, and that's where they survive the best. We'll go about a couple hundred yards this way to make sure the wall's not there and then come back. That's a rower. Looks good. Looks good. Let's go put it in. The first instrument is an acoustic Doppler current profiler. It sits on the bottom and sends 4 beams upward into the water and listens to the backscattered sound coming back. We then can convert that sound returning into currents. The way we do that is listen very carefully to the change in sound as it moves. It's like a truck coming by when you're standing beside the road, the Doppler ship. Though the ocean is very big, 2/3 of the world, the number of oceanographers are remarkably small. 500,000, 2,000. The problems are big. We often form international teams to go study them. It helps in different perspectives. It helps with multinational funding of programs. And there's a good sense of community and camaraderie throughout the oceanographic community. Professional societies in our business are the glue that hold us together. They provide forums for exchange of scientific results. These are the mechanisms to get people together. All our climate and our future resources are based in the sea.
The management of water is a key issue for geoscientists, especially water quality issues in urban settings.
Watershed protection. This is Debbie. This is Deborah Williams. As an environmental geologist with the City of Austin, it's my responsibility to review proposed developments for subdivisions and site plans to comply with watershed regulations and environmental regulations. The major water issue for the City of Austin is that there is an aquifer-related formation called the Edwards Formation that runs through the city of Austin, and to the east of that is a non-potable formation that needs to be differently regulated than the section that is in our recharge zone. And so the focus is to have responsible development on either side. Development sites in the Edwards Aquifer are required to have water quality controls that include sedimentation and filtration. The design of water quality controls in Texas need to take into account that the rainfall is sometimes intense over a short period of time. Water that hits impervious covers such as roof, runoff, and parking lots go first into the sedimentation chamber of a water quality control and then into the filtration phase where it's supposed to draw down at a certain rate to remove contaminants before the clean water hits the Edwards Aquifer. I would need to look at the liner that connects the rock berm that would separate the sedimentation and filtration. One of the most important features of a non-structural design is stabilization of slopes that are earthen with vegetation. That does not allow for failure of the berm walls and will contain the amount of runoff that is supposed to be captured from the impervious cover. I would check to make sure that the inlet pipe discharges at a point that splays the water so as not to create a point of erosion in the pond. When I review zoning applications in the office, the first thing I do is I check the parameters of the proposed development on the Geographic Information System. When I go to a site after construction to look at their structural water quality control, I check to make sure that the walls of the control are maintaining their integrity, that the sand filtration media has no vegetation in it, and that the liner has not been compromised. I looked to make sure that the site has been revegetated in the area of work within the limits of construction, and that if revegetation is still going on, that the erosion and sedimentation control measures, usually a silt fence, are still in place until that area of disturbance has been reestablished. The best thing about being an environmental geologist is that I get to work with customers, and even though they may have polarized interests, there's an opportunity to help someone to achieve their development needs while preserving the natural and traditional character of the area that's being developed.
Geoscientists investigate the past as a way of interpreting the present and predicting the future.
My overall task as a researcher is to improve the general understanding of how rivers behave over long periods of time, and with a particular emphasis on the magnitude and frequency of large floods on rivers in the western United States. As a beginning student in the earth sciences, I was interested in mountain building processes and structural geology and things like that. As my education continued, I started to become more interested in dynamic surficial processes that are acting everywhere around us as we speak, basically. And eventually that evolved into a primary interest in geological catastrophes and big floods and debris flows, volcanic eruptions, things like that. Things that I felt had an interesting interrelationship between humans and the surface of the earth. We're using physical evidence left in the wake of recent large floods on the Truckee River to help us interpret the geological record of larger floods. One of the most relevant applications of this type of research is extending the record of flood events in real time to help us improve the analysis of the frequency of floods in a statistical way. Most statistical analyses of floods are based on very limited records, oftentimes in the West less than 100 years in length. And we do a study like this, and we can extend that record by hundreds to thousands of years. In general, the flood debris contains very light organic material and twigs and sticks and things that float on the water surface, so it helps to define how deep the water was at a certain point. But it also may contain different types of debris, including varieties of trash that I can actually use to determine the timing of the flood that emplaced the debris. As an example, I have found many beer cans in flood debris in different parts of the western United States. And in one study in western Arizona, I used a variety of beer cans to help reconstruct the history of floods in an area with no stream gauges or rain gauges. The dimensions of large boulders that have obviously been carried by floodwaters can be used to reconstruct the hydraulics of the flow, like the velocity, sometimes the depth, and the magnitude of the flood. We have chosen to study a reach that includes a United States Geological Survey gauging station for us to use to help calibrate the magnitude of the floods that we find in the stratigraphic record. We use the flood stratigraphy in combination with some methods of geochronology to determine the magnitude and the frequency of the floods that left the deposits behind. As we collect the stratigraphic information in the field, we carefully reconstruct the exposure in our field notebooks. My primary research interest is in rivers and floods, and we've found that in general, whenever there's a large flood in a certain region, there's a great interest in our sorts of studies because they can provide much more insights into how frequently these types of floods happen. I've chosen a career in the geosciences because of my love of nature and attempting to understand all the different things that I see on the Earth's surface around me. And I have taken this particular track of understanding river processes because I feel like it has a broad social relevance.
Oil and gas are key resources for society's energy requirements. The exploration and production of petroleum involves over 40% of all geoscientists in the United States. A range of different geoscience professionals work on the search for oil at different stages of the operation. Exploring likely rock formations and analyzing core samples, examining the chemical composition of rock samples taken from the field, advising oil exploration companies on the efficient use of technology in their operations, and interpreting geophysical data to determine likely places to drill for oil and gas.
I have a lot of different tasks that I take care of each day and throughout the year. One of them is I provide research application support for our affiliates, which means I travel all around the world. Another responsibility is research. I conduct my own research, working with a team of people here at Exxon. That involves a lot of field work. I also mentor a lot of the newer staff members as they come in, help them understand how the corporation works and transfer technology to them. The overall mission of Exxon is very straightforward. Our mission is to return profit to our shareholders each year, and to do that in a responsible way that is environmentally sound and also fiscally correct. Field work is the most interesting part of my job. We describe sections, measure sections, using Bruntons and Jacob staffs. We collect samples, bring those back for laboratory analysis. We take a lot of photographs. We do a lot of photo panorama work. We rent helicopters and do flybys of the outcrop in order to photograph from the air. We use radar satellite data in order to interpret the surface features that we see in the outcrop. Core description is a fairly tedious and laborious process. You use a hand lens to describe grain size. You describe the sedimentary structures of the bedding types that you see in the core. You look at the color and the trace fossils and the other fossils that you find, and you record all this on a data sheet, which is then entered into a computer later on. I deal with several related Earth history issues. One, of course, because I work for Exxon, is the search for energy. That's very important to us. And being an oil company, we primarily look for oil and gas, not geothermal energy. The other important part of my job is understanding the evolution of Earth history. I would call it paleogeographic reconstruction. throughout geologic time, because that's the way that we develop the concepts that we can then pass on to our affiliates to help them find more oil and gas. The thing I like most about working in the geosciences is the field work that I do and the discoveries that I make to see all these different observations come together into one coherent understanding of the rocks is a real thrill. The most important attribute that a person brings to their work is a sense of enthusiasm. And with that characteristic, they can do just about anything.
I've been with Amoco for 10 years. I'm currently a technology planning coordinator in the technology group.
Scott, I just wanted to show you the fast diagram that Mark Anderson...
Amoco's main goal is to increase shareholder value. We have 3 parts of the corporation: exploration and production, chemicals, and refining. And I'm in the exploration and production part. I started at Amoco's research facility in Tulsa, Oklahoma, in the geochemistry lab, and I was a consulting geochemist, and I did that for about 4 years, and then I had an assignment in the London office where I was the geochemistry coordinator for the UK exploration. Geochemists typically look at rocks that some other geologists aren't necessarily interested in, because we're interested in source rocks. And we may obtain samples from numerous sources, either well cuttings, outcrop samples, and those samples are laid out at the core facility. Boxes of samples arrive from all over the world and are cataloged at the warehouse here, so they're available for anyone who wants to look at them.
I'll just stop and kind of point something out here.
As a geochemist, I work with a lot of other geoscientists, other geochemists, as well as paleontologists and stratigraphers.
Is this all of these samples have this kind of material?
Right. One thing really great about Amoco is that I've had the opportunity to travel places all over the world. I've been to Caracas, I've been to Norway. Svalbard was the most amazing place I have ever seen. The glaciers, the exposures, the geology was just really breathtaking. And I think I took 10 rolls of film because I thought, I'm probably never going to see this again. And it was really fantastic because I thought, this is work. This is a part of a project. And I get to go somewhere like this. 2 things really give me the greatest thrill about being a geoscientist and working for an oil company. And one is the actually finding the oil and gas. It's like finding a treasure. And the other is just being able to work with so many different kinds of people and the daily interaction. People from all over the world with different backgrounds and different knowledge bases, and just enjoying working with people.
Landmark's mission is to lead in creating a new era of finding and managing oil and gas reservoirs through integrated information solutions that have a dramatic business advantage for our customers. Traditionally, people have taken what they've done on paper and just transferred that to the workstation. And what we want to do is show them that there's a lot more within the workstation you can do if you can go past that mindset. The products that Landmark sells are used broadly in exploration and production areas of the oil industry. I work very closely in the exploration area and spend quite a lot of time talking to customers about how they explore, how they use the software, and how they would like the software to be developed to help with their exploration. The geoscience issues that we are involved with is everything to do with the oil exploration, with energy, right from how to find it in the ground, actually right through to how to take it out of the ground and how best to do that. One of the greatest thrills that I've got out of being a geoscientist is actually being involved in presentations at major trade shows like the SEG, standing up in front of 50 or more people with our computers there and being able to show the software in a new way and watch their faces and realise that I didn't know I could do that. I think there are really good opportunities in the oil industry and geoscience for college students who are considering it at the moment. I've certainly found that I've had a lot of fun. It's been very diverse. I've changed my focus of my career quite a few times and always found that I really enjoyed each side of the geosciences that I've worked on.
My job is to explore for oil in the deep water region of Nigeria in West Africa, part of the West Africa team here. And nobody really tells me how to do my job. What I actually do is use whatever tools are available, my discretion to actually explore for it and determine what blocks we want to pick up, what blocks we want to drill, and where to drill them. Working in the Nigeria team, our job is to examine the Texaco-operated and Texaco interest blocks, predominantly in the deep water region of Nigeria. Offshore blocks in Nigeria can be anywhere from 500,000 to 750,000 acres. These are huge blocks. OPL 216 is a somewhat risky block in that the water depth is considerable. This is leading edge technology in these water depths. But the potential is 3 really huge prospects that have the really the capacity to be 500 million to 1 billion barrels of oil. What shooting a block means is that we go out into the block with a seismic boat. Now this boat will tow anywhere from 4 to 6 cables. The cables will be 6,000 feet long. And it bounces a wave, a sound wave, from the boat down into the ground and then back up to the cable. Computers play a big role in my job. I couldn't do my job without them. And what I use primarily is a PC and 2 different kinds of workstations. There's a Sun workstation, which I use landmark software on to interpret my seismic data. Then there's also a Silicon Graphics workstation, which I primarily use for visualization software. In modern geology, teamwork plays a big part. For example, a team used to consist of a group of geoscientists that all worked on different projects on the same floor. And that wasn't really a team. Teams nowadays consist of geoscientists, possibly 2, a geologist and a geophysicist, as well as an engineer and a land person, all working together. Texaco takes its environmental responsibility very seriously, and as such it will never be the low-cost producer because it doesn't cut corners on environmentalism, and I really like what I see here. Balancing travel with my personal life means that my wife has to be understanding to a certain extent. The family knows that Daddy has to go out of town sometimes, and for the most part, if I have enough notification ahead of time, my wife can make allowances in her schedule for it and to be home. Ultimately, there is only one real test for how good a petroleum geologist is, and that is with the drill bit. And if it's a discovery, then everybody's fine. If it's a dry hole, it's back to the drawing board. It's a continuous learning process.
Understanding the dynamics of Earth systems is a concern for many geoscientists. This concern is also shared by the government. The United States Geological Survey, or USGS, is an important agency within the U.S. Department of the Interior.
Thank you. I'm very well. Have a good day. You too.
The USGS is the largest Earth biological, hydrologic, and mapping organization in the federal government. Right now, the current employment is about 11,000 individuals. And in fact, in the last year, with the addition of the Biological Resources Division, we're the largest group of ecosystem-oriented individuals in the federal government. Since 1974, I've had an interest in the Bering Glacier. The Bering is the largest glacier in continental North America. It's about 150 miles in length, has an area of over 2,000 square miles. It's larger than the state of Rhode Island. Originally, I became involved with Bering because of the potential for large outburst floods coming from the glacier and having an impact on offshore oil and gas or onshore oil and gas facilities. With time, that emphasis has changed to the present studies that I'm involved with, looking at the impact of global warming or local climate change, regional climate change, on the Bering Glacier, and in fact the changes around the margin of the Bering Glacier. We use remote sensing as our primary information source, so we're looking at both satellite imagery and aerial photography. And we normally will make observations in this imagery, and we'll go out in the field by boat or on foot to check out things that we have observed on the photography or the satellite imagery. And then we use our own oblique aerial photography, mostly from small aircraft, to get detailed photography and photographic records of these features that we're observing so that we can document the rate of change and the type of changes that are occurring. Hang on to that end and let me even roll it right here over the table. That's good. Let me show you where we're going to be this summer. One of the most important aspects of our laboratory activities is the development of a geographic information system, a computer-based information system for the Bering Glacier. And in this we include our observations, a lot of geophysical data, a lot of our digitally remote sensed information, and we build a multi-layered picture of Bering Glacier at various points in time, including the past, the present, and the future. The thing I enjoy most about geology and being involved in the geosciences is the ability to travel virtually anywhere on Earth and, with a quick visual inspection of where I am, understand the type of processes that had existed in both the recent past and the long geologic past that created the landscape around me. If I was a student in college today, I would consider the geosciences for several reasons. It's a career that gives you an opportunity to work outdoors, hands-on, dealing with the Earth. And as we're becoming more and more focused on a stewardship strategy for not only this generation but for future generations, there's going to become a much greater dependence on understanding how the Earth system works. The geoscientist is the individual who provides this information.
The geosciences address both the resource requirements of today's society and investigate and manage the environment. The more we understand about Earth's systems, the more we recognize the need to know more. The need for new geoscience professionals will also grow. Currently, there are about 125,000 geoscientists working in the United States. 40% work in oil and gas exploration and production, and another 15% in the minerals industry. Over 30% work in environmental areas such as environmental protection and geologic hazards. And an additional 10% address issues of climate and the atmosphere. About 5% study the oceans as their primary focus. If you find the exploration, discovery, and stewardship of our planet an exciting and challenging prospect, you may want to investigate the geosciences.